Okay, students, we're going to go over the S lesson today. This lesson is entitled the S lesson because all of the terms either start with S or have a major S in it. Do you understand?
I understand.
Okay, the first S is solution. Students, a solution is an example of a homogeneous mixture. And I said probably in the last class that pure scientists call solutions and homogeneous mixtures synonyms. They basically take the solution, in other words, evenly mixed down to the microscopic level. But from an engineering background, homogeneous doesn't go all the way down to the microscopic level. So I'm teaching it from my own background where we won't call solution a synonym of homogeneous mixture, but we'll call it an example of a homogeneous mixture. So solution has two main parts. Does anybody recall the two parts of a solution? Yes, Amy.
Solvent and solute.
Okay, it's pronounced solute, like with a Y in it, but there's no Y. Solute and solvent. The solute is the smaller substance that dissolves into the larger fluid. Okay?
Yes, sir.
All right, examples of solutes. We gave some great examples last time. Examples of solutes are, first of all, sugar into Kool-Aid. Okay, now I know sometimes the Kool-Aid packet already has sugar in it, but even the Kool-Aid mix would also be a solute. Okay?
Kool-Aid is also good.
Right, Kool-Aid would be the solution. Sugar and the Kool-Aid mix would be two solutes. What would be the solvent? Eddie.
Would it be the water?
Yes.
Yes.
The water is the solvent. So the solvent is the fluid that dissolves the solute. Hank, try to pay attention back there.
I apologize.
So the solvent is the fluid that dissolves the solute. Okay? Now, water is known as the universal solvent. Usually the solvent on this planet is water. All right, so we know the solute, we know the solvent. Our next term is soluble. Does anybody know what soluble means? Eddie.
Can I take a stab at it? Is it something that if you put it into a solvent, it does not solve or solve?
Close.
Good
Close.
stab, good stab.
Okay, Francesca.
Does it mean able to dissolve?
It is able to dissolve. Soluble means able to dissolve. So substances are either soluble or insoluble, which means either they can dissolve or they can't. Does that make sense, y'all?
Thank you.
All right. So that's what soluble means. Our next term is a little bit different than soluble. It's solubility. All right. I'm going to give two definitions of solubility. First definition is the ability to dissolve. Solubility is the ability to dissolve. So in other words, examples of solutes are salt and sugar. They both are solutes that can dissolve in water. Right, class?
Yes, sir.
Yes, right, sir.
So if they both are solutes, they both are soluble. The question is, how soluble are they? The degree at which they will dissolve, that's the solubility. Okay, so solubility indicates how much of a solute can dissolve into a particular volume of solvent. And there's an equation for it. Solubility solubility is equal to the mass of the solute that can completely dissolve in a certain volume of what class? Solvent. So that's what solubility equals to. Solubility refers to the amount of solute that can completely dissolve into a certain volume of solvent. An example, let's say the solubility of sugar, which would be capital S, equals 2 grams per milliliter, as an example. What that means is you can place 2 grams of sugar into water and those 2 grams will dissolve. Does that make sense? So that's how soluble sugar is.
If the solubility
If the solubility was equal to 2 grams per milliliters.
Right.
Yes.
Will you please repeat the second definition of solubility?
All right. The first verbal definition is the ability to dissolve. That's the verbal definition. The mathematical definition is the amount of solute that will completely dissolve into a certain volume of solvent. Okay? All right, so that's solubility. Now, in all of these definitions, or most of them, we've used the term dissolve. Let's go ahead and define that term. Students, dissolve means to evenly blend in. Dissolve means to evenly blend in. Dissolve means to evenly blend in. Okay? And I want you all to just think about dissolve versus a chemical change, okay? Dissolving, y'all, is not a chemical change. If something dissolves, it is a physical change. It's not being destroyed. Are y'all understanding what I'm saying?
So you technically you could remove the whatever.
The solvent.
Yeah, the solvent out of it.
You can remove the solvent and the solute will still be there.
Yeah.
All right.
Yeah.
Very good. Very good. So, in other words, think about it like this. Salt is a solute in salt water, right?
Right.
The salt is the solute. The water is the solvent. The salt water is the what? The solution. Okay? Does salt water taste salty?
Yes, it does.
Yes. Does Kool-Aid taste sweet?
It does.
Yes, it does.
Yes.
The reason why salt water is salty, the reason why Kool-Aid is sweet, is because the sugar is not being destroyed. It's just blending into the water and the Kool-Aid mix. I got it? The salt is not being destroyed. It's just blending into the water. Okay? As opposed to, for example, if you pour acid on an object, it's not the acid is not dissolving the object. It's changing the object chemically. It's creating new substances. Okay? So solubility is not a chemical property. Solubility is a physical property. Dissolving is not a chemical change. Dissolving is a physical change. All right, the last term that I'll teach y'all is saturation. Saturation is the point at which no additional solute can dissolve into a given amount of solvent. I'll say it again. Saturation is the point at which no additional solute can dissolve into a given amount of solvent. That's called the saturation point. Okay? Let me give you an example of saturation. All right. First, let's get a beaker. Let's say, for example, we have 200 milliliters of water in this beaker. Let's say the solubility of some random substance is equal to 50 grams per milliliters. Okay? If the solubility is equal to 50 grams per milliliters, that means only 50 grams. I'm sorry. That's way too much. Let's say the solubility is 0.50 grams per milliliter. That's more realistic. Okay? So let's say that an object has solubility of 0.50 grams per milliliters, which is like 500 milligrams per milliliter. All right? Now, here comes some math. Y'all ready for some math?
Yes, sir.
How many grams of this particular substance, this red substance, could dissolve into this 200 milliliter volume of water? Francesca.
100 grams?
Okay, she says 100 grams. Here's the way that works. As opposed to showing y'all the equation, you all are more comfortable with proportions, aren't you?
Yes, sir.
All right, so let's set up a proportion. So solubility is a ratio of how much solute can dissolve into a certain amount of solvent, right?
Yes, sir.
So if 0.5 grams can go into 1 milliliter, by the way, that milliliter is like 1 milliliter, right, y'all?
Yes, sir.
Then how many grams can go into 200 milliliters? So I'm relating it to math. Okay? So as soon as I do that, y'all know what to do, don't you? You cross multiply and do some magic. Notice when you cross multiply, the milliliters cancel. You'll get 0.50 grams times 200 milliliters equals X times 1 milliliter. Y'all see what happened?
Yes, sir.
And then to solve for X, you divide both sides by what? To isolate the X, you divide both sides by 1 milliliter, and those milliliters cancel. And when those milliliters cancel, you'll see 0.5 times 200, and Francesca did a great job with that math. That's essentially half of 200 is 100. The unit that's remaining is 100 grams. Now take a look at that, y'all. Is 100 grams into 200 milliliters the same ratio as 0.5 grams into 1 milliliter?
Yes, it is.
Yes, it is. Yes, it is. All right. All right. One more thing. Let's say you have a container of solute, and here's this red solute that has this density of 0.5 grams per milliliter. All right. In this particular sample, let's say this sample you have 120 grams. If you place this 120 grams into this solvent, do you know what's going to happen? So students, solubility says how much will dissolve. Okay? So the solubility of this material says that 100 grams of it will dissolve in this 200 milliliters of water. What happens to the other 20 grams? It doesn't dissolve. And y'all are probably familiar with that, aren't you?
Sediment.
If you put too much sugar in the Kool-Aid, what happens to that extra sugar? Because it's more dense than the solvent, it will sink to the bottom of the solvent. If it were less dense than the solvent, it would do what? It would rise to the top.